For section 331, example 4, we are going to continue with graphing quadratics using the functions and the characteristics that we've already talked about. So in example 4, gives us the quadratic function g of x equals negative x squared plus 8x minus 17. It says to determine the direction in which the function opens, the vertex, the equation of the axis of symmetry, the x-intercept or intercepts, depending on how many we would have, and then, if any, the y-intercept, and use this information to sketch our graph. So the first thing we're going to find or look at is determine the direction of which the function opens. Remember, to determine which direction it opens, we're going to use our a value. So in this particular equation, we have an a value of -1. We have a b value of 8 and a c value of -17. So we are going to be using our a value. If our a value is negative, if our a value is less than 0, our graph is going to open down, which means we would have a maximum up at the top. So when we do find our vertex, we would know that it is a maximum. So we've done our first part. The second piece says to find the vertex. Now remember, our vertex is a two-step process. The first piece is we're going to do negative b over 2a. That's going to find the x value, and then we're going to plug that back in. So using what we know, negative b over 2a would be -8 over 2 times -1. This simplifies to 4. Now what we do with 4 is we plug it back into the original equation. Everywhere we see a variable, or in this case an x, we're going to replace it with that 4, plug it into a calculator to see what comes out. So if I plug in a 4 for each of these positions, type that in, we get a -1, giving us a vertex at 4, -1. So remember, that's from finding our a value. That is our maximum because our graph is going to open down. The next thing it asks us to find is the equation of the axis of symmetry. Remember that axis of symmetry is the x value of our vertex, and it's the vertical line that splits our graph into two equal pieces. So that's what helps us find our missing coordinates, our missing points, once we go to graph. So we have an axis of symmetry at x equals 4. Next piece, it says to find our x-intercepts. So our x-intercepts, those are what we've been solving for the last few days using the quadratic formula. So we're going to use the quadratic formula again. So in order to find our x-intercepts, we are going to take quadratic formula, negative b plus or minus the square root b squared minus 4ac all over 2a. So if we plug in that information, we would have -8 plus or minus the square root of 8 squared minus 4 times -1 times -17 all over 2 times -1. Now remember, when we simplify these, we want to simplify piece by piece. So the first piece we're going to work towards is just simplifying what's underneath the radical. So we leave the -8 plus and minus the square root out in front, leave all that, and we're just typing in what 8 squared minus 4 times -1 times -17 is, and that's going to give us a -4. Now before we go any farther, remember when we talked about the discriminant, that number that is underneath, anytime this number underneath is a negative number, we instantly have no solution. We have no x-intercepts. So a negative number tells us that we have no x-intercepts. So that all that means is we're still going to have a graph. It's just never going to cross the x-axis. So the last piece of information we have to find is going to be our y-intercept. And if you remember, the y-intercept is simply at our 0, c. So our c value in this case would be 0, -17. So So we're going to use all these pieces of information, all these coordinates that we found, to put a graph together. So if we start with the pieces we know that we have a vertex at 4, -1. So there's our vertex at 4, -1. Same dot right here, we know that this is our axis of symmetry. So we know that this line at x equals 4 is going to go perfectly through the middle. So whatever we have a dot on the right, the same dot is equal on the left, and vice versa. We also know that we have a y-intercept at 0, -17, just down there on the left. We have no x-intercepts, which makes sense because we know our graph is going to open down from our blue vertex and go through our y-intercept. So we'll zoom in on our graph. This isn't very much information to make our graph from, so that's why we're going to use that axis of symmetry. If we know that we have a y-intercept at 0, -17, this dot is 1, 2, 3, 4 spots away from our axis of symmetry. We can go 4 in the other direction, 1, 2, 3, 4, and know that we also have a dot on that side of the graph. So what this allows us to do is create that symmetrical quadratic parabola going through dots on both sides. So we found all the pieces, put what we knew on the graph. We know we have no x-intercepts, which our yellow graph never touches that x-axis, opens down, vertex at 4, -1, axis of symmetry at x equals 4, and a y-intercept at 0, -17.